All right, now on to piecewise functions. Now we talked about these a little bit. Think about it as a function that can't really decide what it wants to do. It changes its mind as the x value changes. So here's a piecewise function. So we want to figure out what its values are going to be for these different inputs. So here, if we want to do f of -1, I want to say, okay, well, is -1, is that less than 0? Yeah, it is. So I want to do this top thing, and I'm not going to do the bottom thing. So I'm going to do 2 times -1 plus 1. Which is -2 plus 1, so it's -1. So f of -1 is -1. Then we do 0. Is 0 less than 0? No, it's not. Is 0 greater than or equal to 0? Yeah, it is. So we want to do this bottom thing. We're going to do 2 times 0 plus 2. So that's 2. Cool. Next, we got f of 2. Is 2 less than 0? No. Is 2 greater than or equal to 0? Yes. So I want to do this bottom thing again. So we're going to do 2 times 2 plus 2. So that's 4 plus 2 is 6. Sweet. All right. Now this one's sneaky. So we've got t squared plus 1. T squared plus 1, is that less than 0? Well, basically this question is asking me, is it positive or is it, is it negative or is it positive? Well, I know that t squared, if you square something, it's always positive. Like if you square a negative, it's positive. If you square a positive, it's positive. So I know this is a positive value, and then I'm making it bigger. So it is a positive value. It is bigger than 1 because it's been plus 1. So I know whatever this happens to be, it's got to be positive. So I'm going to do the second thing. If you need to hear that explanation again, you might want to rewind the video. So we're going to do 2 times t squared plus 1. And then we're going to plus 2. So this turns out to be 2t squared plus 2 plus 2, which is 2t squared plus 4. Neat. All right, now I want to draw the graph of a function. Now, when you want to graph these things, the best way to do it is to graph it as if it was just a regular old function and then erase what you don't need. Next, we want to find its domain. So when we're checking our domain, we see if there's any problems where we wouldn't know where to put our x's. We know where to put everything that's less than 1. We know where to put everything that's bigger than 1, and we know where to put 1. So we don't have any problems for our domain. It's going to be -infinity to infinity. Our range, however, does have a problem. You can see that this thing never goes below this point right here. That's as low as it goes. It goes up and up and up, but it never goes lower than that. So our range does have some issue. Our range, our lowest point is 1, because we're checking our y values for that, and it goes up to infinity. All right. Now, our last problem of the day, we're going to write our own piecewise function. We can see we've got 1, 2, 3 pieces to this piecewise function. We're going to write an equation for each one and then determine what the intervals are for each piece. Our first one is right here. Actually, I'm going to start with this one because it's really easy. It's just a y equals the same number over and over and over again. It's y equals -1. This is just a flat line. Next, I'm going to do this one. Well, no, let's do this one. Let's do this one next. So it's got a y-intercept at 2, so I know it's going to be +2. And if I can get a slope, I've got point slope form, and I can totally get a slope. It's going down 1, 2, and over 1. So its slope is -2. Finally, we've got this one. It has a y-intercept at 0, so I don't have to write anything. But what's its slope? It seems to be going up 1 and over 2. So it has a slope of 1/2 and an x. Next, we're going to check our intervals for each one of these pieces. Here, let's do this one first. We'll do it in reverse order again. So that one is between 1 and 3 in terms of our x values. So it's between 1 and 3. X is between these two. Now at 1, we have an open circle, and at 3, we have a filled in circle. So we're going to have an equal to at 3. Our next one is between 0 and 1. At 0, we have an open circle, so we're going to leave it without an equal to. But at 1, we have a filled in circle, so we want an equal to. Do that one more time. Our last one is between -2 and 0. Both of them are filled in. Since both of them are filled in, we're going to give both of them equal to's. And that's it. I think, I'm pretty sure. I think that's enough. So basic things about functions is if you've got a function, you put one in, you get one out. For your domain, that's everything that you put in. Watch out for no negatives and square roots and no zeros in your denominator. Your range is everything that comes out, and they often will match with any sort of issues you've got with domain. Make sure you've got your happy function book and that transformations table, because that's really, really important. Bye-bye.